So since you guys showed up, we could do a review, and I could ask you questions if you want me to, but you could start with questions. Hi, Maria. Hi, Jordan. Hi, Jason. Liam. Okay, so today's exam, well, that's not exam. I guess interview 3. It's like an in-class quiz where you're going to be taking it in class. And it'll start at 9:45, and it's a 3D problem, and it's a standard statics problem. So what questions do you guys have? Hi, Tony. Hi, Colin. Jason.
Are you including friction or anything like that, or
No friction. I didn't include
loads?
friction. What?
Distributed loads?
No, there's no distributed load either. Yeah. I don't think we've seen a 3D problem with distributed loads.
We seen them like with center of gravity, but not with distributed.
Yeah. Yeah. I mean, certainly all life is 3D, right? So there are 3D distributed loads. It just in statics or in engineering, we tend to simplify things to being a 2D unless we can't. Okay,
Well, that you could solve with the centroid.
What?
I mean, essentially, a 3D distributed load is something you'd solve with the center of mass.
Yeah, we just haven't seen those problems, but you'll know how to solve them. But typically distributed loads we look at, but yeah, you're right. Where is it centered? It would be centered in its 3-dimensional center, like the center of its area.
Center of weight.
Yeah. Okay, questions?
Joanne, are we going to need our graphing calculators to solve this?
Yeah, usually 3D problems, on 2D, you could usually find one equation that has one unknown and then plug it into the others. But in 3D problems, typically you can't. So you're going to need to do it as a, 5 equations, 5 unknowns, or 6 equations, 6 unknowns. So yeah, you will need your calculator.
Okay.
Hi, Myra. Hi, Eric. Hi, Jack. Hi, Colin. All right, so then I'm going to ask you questions if you're not asking me questions. So Colin, what's the first step in solving a 3D statics problem?
Look at what information the problem gives you and what it's asking you to find.
Okay, so the given and the find, right? In the given, it's anything in the words that's not in the picture, and then you also write sketch info. And then from our last discussion on find, rather than writing something like reactions at point C, write down what those forces are that are unknown. AB, AX, AY, CY, did everybody hear that? So for the find, write the actual unknowns and make sure that the variables you use to represent a force or a moment is the same variable that you represent in the find, same variable in the table, same variable you use on the free body diagram, right? We want to be clear. Okay, Daniel H, is he here? No. David, LR. David here yet?
Yeah.
Okay, David, after given and find, what's the next thing to do?
You want to do your table of forces, magnitude and direction.
That's right. And moments too, right?
Yeah.
A moment could be given, a concentrated screwdriver moment could be given, a concentrated moment could be given, and maybe the magnitude's known or not known, so the table. And David, what do you get from the table? What is the ultimate conclusion from your table?
Your amount of equations and unknowns and free body diagrams needed.
Right, so the number of unknowns that you have determines the number of equations, which determines your free body diagram. Okay, Elizabeth here? Yeah, Elizabeth. After the given and find in the table, what's the next step?
You draw the free body diagram.
Right. And for forces, what needs to be included in a free body diagram, Elizabeth?
For what? Sorry.
For a free body diagram, what do you need to include?
Forces.
Okay, the forces, either their magnitude or the variable, right? So
Oh,
if the
yeah.
force is 100 pounds or you're calling it AX, you have to label it. You have to label it with either the magnitude, the value, or the variable. What else do you have to represent about the force? What else do you have to show?
I don't know.
Well, a force is a vector, right? So you have to show its magnitude and
Yeah.
its
Direction?
direction. So you either have to have distances or angles. You know by now that life is usually in distances and not in angles.
Yeah.
So if they give you distances, you use distances. Don't convert to an angle. Their rounding errors can happen. You can make a mathematical mistake. It's an extra step. So for forces, you definitely have to have the forces labeled with either its value or a variable. You need to have the direction shown with angle if given or distances. Okay, let me go on. Eric, you here? Gerardo, you're here? What else do you need to include on a free body diagram?
Your X, Y, and Z axis.
You have to include your axes, that's right. And when you're drawing something, always for a 3D problem, always look in the picture, right, to see where the X, Y, and Z is, right? Because sometimes X comes out at you, sometimes Z comes out at you, so you don't want to screw up that. You want to make sure that the axes you're drawing are the axes that are given. So if a force is in the X, you know you're drawing it in the X. And then remember, whenever you draw anything in the X, just draw it parallel to the X axis. If you're drawing anything in the Y, make sure you're drawing it parallel to the Y. And if you're drawing it in the Z, make sure it's drawn parallel to the Z. So to make them neat. And don't draw tiny free body diagrams that you can't read. Make it a half a page. You know, in this case, I guess we waste a little bit of money, but draw it a half a page. Draw
Not a
it big.
waste.
Jason, what?
Not a waste.
Not a waste, correct. Not a waste, that's right. Talking like a true engineer. So draw a free body diagram big, use your ruler, make it neat. Okay, any other suggestions on free body diagrams? Axes, label the forces, show the directions of the forces. Check to make sure the variables you're using in the free body diagram are the same that's in the table and the same in the given and the find. Okay, Hyoji, not here. Luis? Matthew? Myra? Okay, after the free body diagram, what's the next step? Myra?
Yes.
After given, find, table, free body diagram, what's the next step?
Find components if needed.
Yep, components and checks. Okay, and why do we do components and checks and not just shove them into the equations, Myra?
So we can catch the error before we move on.
That's right. Okay, so make sure you do a positive, negative check, right? And do actually check it. Don't just write it. And then do the unit vector or the magnitude check, whichever one you need to do. Okay, and then Peter, after the components and the checks, what's the next thing to do?
Need to set up our equilibrium equations.
Correct. And if it's a 3D problem, what's the maximum number of equilibrium equations we have?
6.
6. And what are they?
The forces in the X, Y, and Z directions, and then the moments also in the X, Y, and Z directions.
Correct. And everybody's comfortable with the forces. Since this is a 3D problem, I don't remember it. I did it a week ago, the problem. But yeah, try to see if you could find a problem that has one unknown, but I don't remember if that's the case or not. Now, when you do the moments, you have to decide, are you doing it R cross F, or are you going to do it by right-hand rule? Pick a spot where a lot of the forces converge. Often the origin, a lot of forces converge at the origin. Or if you're picking a point where a lot of forces converge, that might be a perfect place. So be strategic in trying to decrease your amount of work. Pick a point that has axes where a lot of the forces go through them to decrease the amount of work that you need to do. And for me, when I do R cross F, when I do right-hand rule in 3D, I set up that table. My first column represents all the forces present, and the next 3 columns represent the moment in the X, the Y, and the Z about that point. And then remember, if the force is parallel to the line, 0 moment because it's parallel. If a force intersects the line, 0 because it intersects. And then you may have very little amount of moments created. Okay. Victoria? Yeah. Okay, so let's assume now you set up your equilibrium equations, you found out your values. How about if you get a tension to be negative?
It's wrong.
Okay, great, Tony, thank you. What was that, Tony? It's wrong, why? Why, Tony?
Because a negative tension implies that it's a rope taking compression, which can't happen.
Correct, right. And you know the way the tension is drawn. What if, Tony, what if you get a negative for something else?
I mean, as long as it can take compression, it should be fine.
Okay. As long as, yeah, or it's going the other direction, right? So you know the direction of tension, you know the direction in a rope, you know the direction of weight down, and you know the direction of normal towards the body perpendicular to the surface. Those 3 things you know the direction of. If you get a negative for those, you made a mathematical mistake somewhere. But if you get a negative for anything else, what does that mean, Tony? Did he just drop off?
No, I'm still here. If you get a negative for anything else, it just means the force is going the other way.
Correct. Okay, couple more minutes. Any last minute questions before you start? But just stay on. I'm kind of disappointed everybody's not here, but I guess I didn't make that clear. But it's just like an in-person quiz. And so basically I'm giving you an hour, 9:45 to 10:45. And as long as you stay on, if you need extra time, well, then you get extra time. And then there are a few of you who get extra time anyway. All right, so any last minute questions?
Is there anything we're going over after the
No.
interview? Okay.
No, that's all we're doing today is the interview.
So we don't need to be on the call during the entire period, or do we need to be on call?
You don't have to be.
Okay.
I'm only going to stay on until 10 to 11, right? But if you're on and at 11:15 you say, I need more time, if you're not here, you're not going to get more time. I'm not going to start looking at a zillion emails. Okay, this is supposed to be in class. Okay, you guys could get started. You know this shit. You know this. Just be calm, take a deep breath. You start stressing, take a deep breath. You know it. And I'm going to put myself on mute.
It's still locked for another 4 minutes. Or another 1 minute.